I'm Anil Kumar sharing with you questions on trigonometric identity to review for MHF4U. So these are the questions which we had been talking about. I have done half of them in part 1. Now we'll take the other half, including questions like this, right? So let's begin with the part B, which is we need to prove the identity cos to the power of 4x minus sine to the power of 4x divided by 1 minus tan to the power of 4x equals to cos to the power of 4x. Now here the formulas which we are going to use will be simple formulas like a square minus b square to factor the numerator. A square minus b square is equal to a plus b times a minus b, right? So starting with the left side, we know cos to the power of 4x could be written as kind of like this: cos square x whole square, right? Minus sine square x whole square. So now we can apply the formula a square minus b square, where a is cos square x and b is sine square x. I hope you get the idea. Similarly, the denominator could be written as, let me write 1 square. It is not good practice to write like this, but just to make you understand. And tan square x whole square. Perfect. Now we'll apply this formula and write down the numerator as product of their sum and difference. That is to say, cos square x plus sine square x times cos square x minus sine square x. And the denominator can now be written as 1 plus tan square x times 1 minus tan square x. Now you remember two identities which are trig Pythagorean identities, which are cos square x plus sine square x is equal to 1 and 1 plus tan square x is equal to secant square x. So we'll use these. So this is 1. We are left with cos square x minus sine square x in the numerator, and in denominator we get secant square x for 1 plus tan square x and 1 minus tan square x. Correct? Now since everything is in cos, it's a good idea to write tan and secant also in terms of cos. So we could write numerator as such, cos square x minus sine square x, and in the denominator I'll write secant square x as 1 over cos square x, and here 1 minus sine square x over cos square x. Now we can take cos square x in the numerator, rewriting this as cos square x times cos square x minus sine square x, correct? As far as this part is concerned, we can take common denominator of cos square x. So here we get common denominator of cos square x, and then we cross multiply. We write this as cos square x minus sine square x. Correct? As you can see, these two terms will cancel out and this cos square x will go to the numerator. Or let me rewrite this once again. I'll write this as cos square x times cos square x minus sine square x. And here we have cos square x minus sine square x, and I'm writing this cos square x in the numerator. Now clearly you can see it cancels out and you are left with cos square x times cos square x, which is cos to the power of 4x, correct? Which is the right side. So that is how you can prove it. So I hope the proof is absolutely clear. Now let's move on to the next question, which is secant square x minus tan square x divided by cosecant x equals to half of sine 2x secant x. So let me do it from both sides. Sometimes you can actually solve identities from both the sides. So I'll take this opportunity to show you that method. Now let's also look into a few identities which relate tan and secant squares. 1 plus tan square x is equals to secant square x. And therefore, if we want to see what secant square x minus tan square x is, let's put this tan on this side. So we get 1 equals to secant square x minus tan square x. Is that correct? So on the left side, I could write this numerator as 1, right? So we have 1 over cosecant x. So simple. And cosecant is reciprocal of sine. So you could write this as 1 over sine x or sine x. Do you see that? So the left side is basically sine x. Now how about the right side? Let's look into this. We have the number half sine 2x. Now sine 2x could be written as 2 times sine x cos x. Perfect. And secant x is 1 over cos x. Cos x gets cancelled, 2 gets cancelled, and what remains is sine x. So you know left side is equal to right side. Isn't that so simple? Well, the alternate method which most students will do is write secant and tan in terms of sine and cosine. You'll actually fill a whole page to do this. So I'd like you to notice this kind of a solution. That is the most efficient way you could solve such an identity. So let's take up more examples. I hope you find this series useful. Feel free to share your comments and especially the steps which you like the most. Now we have another identity here which is cos cube x minus sine cube x divided by cos x minus sine x equals to 1 plus sine x cos x. So I'll recall the formula a cube minus b cube. It could be written as a minus b times a square plus ab plus b square, right? We are going to adopt this formula to prove the identity. Let's begin from the left side, which is difference of cubes. That is it. So left side, which is cos cube x minus sine cube x over cos x minus sine x, can be written as difference of these two, which is cos x minus sine x times square of the first one, which is cos square x, plus product of these two, cos x sine x, plus square of sine, which is sine square x, correct? Divided by cos x minus sine x. So clearly you could see this factor cancelling off, and you're left with what? You're left with cos square x. Let's rewrite. We'll write plus sine square x first, and then the other term, which is plus cos x sine x. Now cos square x plus sine square x is 1, so we get 1 plus cos x sine x. Correct? So we get 1 plus cos x sine x, which is our expression. Do you see that? 1 plus cos x sine. Exactly what we have here, correct? So that is how, which is right side. You can show that left side equals to right side. I hope that makes sense. So let's move on. Let's take few more examples involving compound angles. We need to prove cos x minus y divided by cos x cos y equals to 1 plus tan x tan y. So we'll just apply the formula, which is cos a minus b. So on the left side, I could write, let me rewrite the question first, which is, it's a good practice. So we'll just expand this, cos x cos y minus sin x sin y. I mean, when it is minus, it is actually plus. divided by cos x cos y. Correct? Now, this is a common denominator to both. So we could write this as cos x cos y divided by cos x cos y plus sin x sin y divided by cos x cos y. Now this factor cancels off, leaving you with 1 plus. Here you can see sin x over cos x is tan x and sin y over cos y is tan y. So we get the right side. Does it make sense to you? So this is tan x and that one is tan y. Perfect. I hope you appreciate it. Here is the last one of this exercise. So we'll look into product of when we have sum and difference. Cos x plus y times cos x minus y should be cos square x minus sin square y. So let's begin with the left side, which is cos x plus y times cos x minus y. We'll just expand it, right? So when we expand it, we get cos x cos y minus sin x sin y. This is from the first term. The other term will be cos x cos y plus sin x sin y. Correct? Now it is kind of a plus b times a minus b. Do you see? If you treat this part as, let us say, a and this as b, right? So this is a minus b and this is a plus b. So a minus b times a plus b is a square minus b square. And therefore, I could write this as cos x cos y square minus sin x sin y square. Correct? What do we need to prove? Cos square x. So in cos we need only x terms, not the y term. Basically, let me rewrite this first as cos square x cos square y minus sin square x sin square y. So we need only cos with x terms, not y. So we'll write this as cos square x and this we'll write as 1 minus sin square y. Does it make sense to you? Cos square y is 1 minus sin square y. That's what we did. And in this case, square of sine we need y, not x. So we'll write this as 1 minus cos square x times, that is sin square y, right? So square sin square x is being written as 1 minus cos square x. You get an idea. Let's expand. So if you open the bracket, distributive property, you get cos square x minus cos square x sin square y. This is minus 1 and I'm sorry, sin square y when you multiply by sin square y. So let me write this as sin square y and minus minus becomes plus, so we get sin square y cos square x. Either way you could write. These two terms cancel off, correct? These two terms cancel. Perfect. So what are you left with? Exactly what you need, which is cos square x minus sin square y, which is the right side. Perfect. So that is how you could do it. So with that, we have completed all the examples we wanted to work with as a review exercise. I hope you find it very interesting. Feel free to share your comments and views. If you share and subscribe, that'll be great. Thanks and all the best.